Hello there. I'm going to do two examples covering 6-1A, which is solving exponential equations. 6-1A problems have something in common, and that's we will be seeing bases multiplying with each other. And when we have the same base multiplying with itself, you can add the exponents together. And so that's going to be step one, is we really have got quite a bit of ick going on the left-hand side here. Let's use purple. So over here, I have 6 to the x times 6 to the x minus 3. Now you might see those parentheses and think, oh, I can't do anything because they're stuck inside. But what that is just showing that they are multiplying with each other. If my bases are the same and they're multiplying, I can add exponents. I keep the base the same, and I am going to show all of my work by adding x plus x minus 3. Equals 6 to the 9th. Now, something you probably noticed in the steps is as we're adding, we have to think about combining like terms. What I mean by that is I can add an x and an x together, but I cannot add an x and a 3. They are not like terms. So if I were to add 1x plus 1x, I would get 2x. So now now I really have 6 to the 2x minus 3. I can't combine that minus 3 with anything because it is just by itself. Now that I have my bases all cleaned up, and I just one base equal one base, I know that my exponents also have to be the same. So step 2, I am going to essentially forget about the bases, and I am just going to worry about setting the exponents equal to each other. This makes solving it a lot easier. I'm going to put my train tracks, and I'm going to get x by itself. And divide by 2. So x equals 6. And once you figure out what the value of x is, you have officially solved the problem. Let's look at another example. So once again, you will notice that we have some mess going on this left-hand side. It won't always occur on the left-hand side, but you will generally in 6-1A have a base times a base, right? Well, we want to clean that up. And in order to clean that up, we need to add these exponents together based on that property. So the base is going to stay the same. I'm still going to have 7, but now I'm going to add x plus 2 plus 3x minus 1. I'm just putting a plus sign in between those exponents. Okay, well, now I'm just going to clean it up a little bit more. Sometimes students will combine like terms as they're going, but I can add the x and the 3x in order to get 4x. And then I can add together the 2 and the minus 1, which is kind of, I could add 2 plus negative 1, or I could do 2 minus 1. Regardless, it ends up giving me plus 1. So now I have a much simpler situation, so I don't have 2 7s on one side. And this is where, just like in the last problem, if the bases are the same, I can set the exponents equal to each other. It's a little bit trickier in this situation because of the fact that we have x's on both sides. So it's not as, easy to do in your head. So that's why it's really important that we set up this equation and we use algebra to solve for x. There's lots of ways that you could solve this problem. I'm going to minus 3x on both sides to start with, which gives me 1x plus 1 equals 13. And then the only other step I have to do is minus 1, so x equals 12. I hope that helped. Let your teacher know if you have more questions.